So here's our first example. A uniform ladder of length 5 meters is of mass 12 kilograms and it leans against a smooth wall and it leans on a rough floor. The ladder is on the point of slipping at an angle of 60 degrees. Firstly, find the magnitude of the reaction force on the wall and find the coefficient of coefficient of friction between the ladder and the ground. So go ahead and try this problem, and when you're ready, come back for the solution. So if we take moments about the ground, so moments about P here, we get minus r omega times 5 sine 60 because we're going to define clockwise as negative and therefore counterclockwise as positive because they're opposite forces. You have to be careful about signs. And then we have the weight downwards, so that'd be 12g times 2.5 cos 60. Because it's the linear distance between this point and P, which meets down here, which is of length 2.5 cos 60, which gives us the reaction at the wall at 34 newtons. Part 2, we know that the friction minus the reaction at the wall, so if we look left and right, resolving left and right, we know that the friction, or the kinetic friction, is 34, which means that mu times Rf, the reaction at the floor, is 34. Excuse me. So if we resolve up and down, we then get the reaction at the floor must equal the 12g at the weight, or at the center of gravity. So the reaction at the floor is 117.6 newtons. Therefore, mu is the frictional force divided by the reaction force, which gives us a coefficient of friction of 0.29.